Hi. So in the next couple of sessions, we'll be solving a problem which is actually pretty easy when you're doing it iteratively. It's easy with recursion as well, but we are doing it using recursion because it'll teach us a lot about recursion, and that will allow us to solve very interesting problems later on. Okay, so the problem that we want to solve is given a list, we want to check if it is sorted. So we are given a list and we just need to check if the list is sorted or not. Okay, so we have a list which has some elements and we want to check if it is sorted. Now obviously it's very easy if you are allowed to use a for loop. What I'm saying is no, let's do it using recursion. Okay, perfect. So how do we do it using recursion? So very simple way to look at this is, let's say the base case, right? So let's first talk about the base case. If my list is of size 0 or 1, then it's by default sorted, right? If you just have one element, is the list sorted? Yes, it is sorted. If you don't have any elements, even then the list is sorted. So by default, that's our base case, right? Induction hypothesis. I'm going to assume that for list of size L minus 1, my function works. Whatever function I have written, I have not written anything, but whatever I'm going to write, I'm going to assume it works for L minus 1. Induction step. The fact that my function works, that basically means it will tell me if this much list is sorted or not. Now my function can tell me two things. Either it can tell me yes, it is sorted, or it can tell me no, it is not sorted. In case it's not sorted, in case this part is not sorted, then definitely the whole list is not sorted. So I can just return false. So if I get a false, I'm going to return false. I don't have to do anything else. In case my function returns that this part of my list is actually sorted, then there is only one part which is left. I just need to make sure that this element is smaller than this element. For example, let's say this was the list given to me, 11, 2, 3, 4, 5. Now this part, is it sorted? Yes, it is sorted. But is the whole list sorted? It's not sorted because the first element is not smaller than the second element, smaller or equal than the second element. So it's not sorted. Okay, so that's how we are going to do this. We have two options. The way we have seen it earlier, we have two options here. One option is I'll check upfront. Before I make a call to this part, I'm going to check if this is greater than this, I can return false. I don't have to make the recursion call in case 11 is actually greater than 2. Because the first number is larger than second. Now irrespective of what is in the rest of the list, this array or this list is not going to be sorted. Okay, so I'm going to first check if this order is fine, then I'm going to call on this part of the list and this will return me the right thing. This function will work fine because I am taking care of base case, I am taking our induction step. The induction hypothesis is going to work fine. Okay, let me quickly repeat our base case. Length is 0 or length is 1, return true. Induction hypothesis, it works for L minus 1 sized lists. Induction step, I'm going to check if the first element is greater than the second element. I'm going to return false because that's not allowed. In case this is not true, else, that means the first two elements are in the right order. In that case, I just need to check for smaller list starting from 1 till the end. I'm going to call my function on this smaller list, and based upon that output I'm going to return my output. Okay, So let's write this code. Perfect. Is sorted. I'm going to get a list. Call it. I don't want to call it L. Let me call it A. Right. Let's store the length of A in L. So I have the length of A. Base case says if L is 0 or L is 1, then I can return true. Then I can return true. So that's taken care of. The base case is taken care of. Now we have an option. You want to call on the smaller list first and then check for 0 and first element, or you want to check for 0 and first element first and then call recursion. Either ways, right? So what I mean here is I have this list. Do I want to do this comparison first and then call on this list, the smaller list, or do I want to do all this work first and then do this comparison? I think it's better to do the comparison first. In case the first element itself is larger than the second element, why to call recursion, why to go through rest of the list, right? So I'm going to do this. In case my list's 0th element is greater than first element, then I can return false. Now if you have reached this point, that basically means your list is of at least length 2. It's not of length 0 and 1. It's of length 2 at least. And the first two elements are correctly ordered. Now we need to call on the rest of the list. So this array A, this list A is this. I want to call on a part of this list. Just one part of this list, not the whole list. And if this part is sorted, then the bigger list is also sorted because the first two are correctly placed. And in case this is false, then I'm going to return false. Okay. How do I get this smaller? Okay. Let me call this is smaller list sorted is equal to, I'm going to call is sorted. And I need to pass this smaller list, the list starting from here till here. I need to pass this. Now that's the tricky part. You basically will have to create a new list B, which will be this, right? Which basically means you're copying everything in A into a new list B. Whatever you have in A, except the first element, you're copying everything. You're making another copy and you're keeping it in B. It's heavy work. If I have a list of 1000 elements, that means I'm copying 999 of them into a new list. For now, let's do this. Right? For now, let's just do this. Smaller list is equal to A. I'm doing slicing, right? So is smaller list sorted? I'm calling is sorted on the smaller list. And now if the smaller list is sorted, then I can return true. If it's not sorted, then I can return false. Again, not needed. This much code is not needed, but it's okay. Right? Let's not worry about that. I could have written it in a single line. I could have just return is smaller list sorted. Because in case it is true, you are returning true. In case it is false, you are returning false. That means you are just returning this. Here you are just returning is smaller list sorted. Because if it is sorted, then you are also, your bigger list is also sorted. If it is not sorted, then bigger list is also not sorted. So either ways, this is also fine. So this code should work, but this is a line which I don't like much, because just think about it. I'm given a list of 1000 size. I'm making a copy of 999 size. I'm calling function on this again. That function is going to make a copy with 998 elements copied and call recursion on this again. Then a copy with 997 elements, then a copy with 996 elements. Huge requirement for space. You're saving way too much data. Okay. Okay, let's create a list. Is sorted, and it says yes, it is sorted. Let's put something else in between. It's saying no, it's not sorted. Seems like our function is working fine. I've told you what's wrong with this function. What's wrong is it is making too many copies of the data that we have provided it. In the next session, we will improve that. We will not make copy of A, instead we'll figure out a way of using the same list in all the functions. Okay, thank you.